Good afternoon, everyone. Today I'm going to give a seminar on the topic Introduction to Z as part of the assignment for formal models in computer science course. One way to improve the quality of software we are using is to change the way in which software is documented at the design stage, during development, and after the release. Existing methods of documentation offer large amounts of text, pictures, and diagrams, but these are often imprecise and ambiguous. So, an alternative way is using the formal methods based upon elementary mathematics can be used to produce precise and ambiguous documentation in which information is structured and presented at an appropriate level of abstraction. This documentation can be used to support the design process and as a guide to subsequent development, testing, and maintenance. So, it seems likely that the use of formal methods will become standard practice in software engineering. Existing applications of the formal methods include the use of probability theory in performance modeling, the use of context-free grammars in compiler design, use of the relational calculus in database theory, etc. The customer information control system is one of the most successful pieces of software in the world, and for this we require a particular formal method. The jet notation is used to specify the new cakes functionality. The jet notation is based on formal specification of systems and based upon set theory and mathematical logic, and it is a notation from formal specification of systems and a formal tool for precise design of software. Z uses mostly familiarly a mathematical notation and properties to precisely specify the system and the description, and also includes standard set operators, set comprehensions, Cartesian products, and power sets as part of the set theory, which is upon which the jet notation is based. Formal methods is a collective term applied to mathematical methods and techniques used to specify, design, and verify systems. Their use has been prevalent in software and complex electronic hardware development, as I have already mentioned before. Formal method, in singular, is a coherent set of such mathematical techniques and notations used as a methodology to specify, design, and or verify a system. JET is one such formal method. So, this means that formal method is a collective term applicable to the mathematical methods and the techniques used to specify, design, and verify the system. However, in singular form, it means a coherent set of that technique and notation used as the methodology. That is one such formal method. Formal methods come under multiple scopes and uses. Level 0, it is used for formal specification. That is when mathematical rigor is used to specify only the requirement of the system. And in level 1, it includes a formal specification plus derivation. This is used when mathematical rigor is used to not only to specify the system requirement but also to derive the specification mathematically. That is to translate the specification of the program. Level 2, it is fully formal. This is when the derivation as from the level 1 is proven for correctness against the original specification. Formal methods may be grouped into three general categories: axiomatic methods, operational methods, and denotational methods. Axiomatic methods in the system is specified in terms of state changes, derived in terms of pre and post conditions, variance, invariance. That belongs to this axiomatic method. Operational method, where the operation of the system is formally specified as an operation sequence like that. And the denotational method, where the system is specified using the domain theory. Z specification. As all other formal methods, JIT uses a powerful notion of abstraction. JIT specifies a system using mathematically defined data types and decompositions called schemas. It is also based upon shared theory and mathematical logic. The mathematical logic is a first order predicate logic. JIT is a specification, as we have already mentioned, JIT is a specification language based on type, states, relations, and functions to express. That is, to express what are the functionalities of the system, what is the desired result, but without stating the how part. That is, it explains the abstraction part. Z is a declarative language. It means that it is non-procedural, unlike Java or C. And JIT notation developed at the Programming Research Group at Oxford University for recording in precise way some of the decisions that are made in the course of software development. JIT, as we have already mentioned, that JIT specification has one of the singular feature of JIT specification is a schema. So what is a schema? A schema describes both the static and the dynamic aspects of a system. The static aspect means that individual states of the system, the invariants maintained, that is, those behavior of the state of the system which does not vary with time. Whereas the dynamic aspect, as we all know, that dynamic means change. It involves the state transitions, that is based upon the input or the some from outside criteria. This transition happens between the states, events, that is due to some operations, some events may occur, or transformations. Due to this events, the states transform from one to another relations, and finally giving the relationship of the input to the output. Next one, the JIT specification defining that JIT language allows us to combine and relate separately defined different schemas in a mathematically logical fashion. That is, it allows us to combine the static and the dynamic system states in a mathematically logical way. JIT also permits a progression of decomposition, that is, decomposition of those states. And we can construct a progression of the related specifications that eventually arrives at the API or the equivalent of the API of an implementation facade. JIT specification language. As in learning to speak any language, you first need to learn some of the vocabulary, rules of the grammar, like that. We also need to be familiar with the grammars of JIT first, to be familiar with how to be actually familiar with this language. Some of the symbols and concepts are unique to Z, but most are generally used in those that are generally used in mathematics. And this JIT specification, we use the object Z dialect of JIT, one that allows for the notion of class, inheritance, and a few other object-oriented approach and features. So here are some of the symbols that we will be unique to JIT. X in a square bracket means type of the X. It simply implies what is the data type of X. X equal to Y stands for Y stands for X, and Z state is a set of integers, and is a set of natural numbers, as similar to the usual mathematical notion. And 1 implies set of positive integers. T belonging to S means that T is an element of the set S. T does not belong means it is not an element of set S, and S is a subset of T, means S is contained in T. Similarly, these are some of the general notations that we use in the set theory and in mathematical formulas. As here is some unique feature. As divide T means symbolizes difference, elements that are in S but not in T. Hash S is the size or the cardinality of S set. D such that P dot T means a set of T such that given declaration D, P holds. Disjoint SQ means the sets in the sequence SQ are disjoint. SQ partition S means the sets in SQ partition the set S. Logic: true or false, it defines logical constants. Not P is a negation P, not P. Similarly, these are some of the formulas that we use in the predicate and the propositional logic. Notations: for all, quantifier, there exists quantifier, equal to, not equal to, implies, equivalence, disjunction, conjunction, if then, those things. And here are the relations that we use in the specification. X cross Y is a set of ordered pairs of X and Y sets. X double implication Y is a set of relation from X to Y. X R Y means that X is related to Y by the relation R, where X and Y belongs to the relation R. Dom R is the domain of relation R. Ren R is the rens of a relation R. Y, that is Y such that Y, for all Y, there exists X belonging to X. X is related such that X is related to Y. As here, this means that the relation R is domain restricted to S, and here it implies that R is rens restricted to S. R tilde, it indicates the inverse of R. And for function, we use this following symbols: X, an arrow with a bar, Y, the set of partial function from X to Y. X implies as a set of total function from X to Y. So here in the partial function we add some bar, and for X total function we use directly the arrow. F of X or F of X means function F is applied to X. And the sequences we use for the operations are sequence sec X means a set of sequences with elements X and drawn from X as the set X. Sec1 X is a set of non-empty sequences of X. So sec X means it may be also contain empty element, but sequence 1 X means non-empty sequences, like in N1 means the positive sequences where 0 is not included. Is equal X means set of non-duplicate and sequences of X, that is all unique sequences of X. Hash of S is the length of the sequence X. Square and this bracket the empty sequence, and x1 to n the sequence of x1 through to xn. Angular bracket x1 to xn and my one angular bracket y1 to yn means the concatenation. So this conjunction means concatenation in the sequence relation. S is equal to S1. Last S means S hash S, since S denotes the length of the sequence. Tell S and S1 equal to S. Front S and angular bracket X means S, where angular bracket X equal to last of S. Ref S is a sequence S in reverse order. Now, defining the schema. Class schema, for example, we have class name, generic parameter, then we have inherited classes, we will need to define the type, then the constant, then state schema, then initial state schema, then operation schema, and finally the history of the invariant. So here is a state schema. Items will be defining with colon, then the sequence of the T, item T. This is the declaration part, and has items is less than or equal to max. This is a predicate. So next one we are going to define the initial state schema. Init first we need to write the keyword init, then items equal to whatever we need to. First we are defining it as an empty sequence. Operational schemas, operation name, declaration. First we have to declare the operation and then the predicates. Like example, in the above example we have max defined as the predicate. And these are some of the decorations or similar decorations. Like name is a constant, name is a type, constant of type T. Item is an input or accepts input. Then item is an output or holds an output. Item has new input of item after change. Delta item, the schema affects change on item. There is some change on the item, and the symbol item is left unchanged by schema. So delta means it is changed and the symbol means it is not left unchanged. So simple example to bring this whole concept together. First we will develop a specification for a very simple library management system. In this system, each book will be assigned to a self location designated by a number. A self location, of course, may house many books. That is our requirement, that is our system. So we introduce the types we need, book and self. By using, as we have already defined, we need to define the type. Means the square bracket means it defines the data type, book data type, and the self data type. So we do not for the moment what exact type of book variable would be. That is the type of the book or the type of the book may be identified by alphanumeric strings, such as by the book title, that is alphabetic, or by author's name, that is numeric, such as by ISBN, etc. It does not matter for the the self we decide is simply numbered from 1 to n. Example, there is set of positive integers, not integers, sorry, natural numbers. So we are going to define this library system. Now we can think of an ordered pair of book self. So which book we define in a particular self, which is generic in with respect to book and specified with respect to self. This renders the whole ordered pair structure generic in that we have to be set to a type of book before it can be instantiated. Now we can create a simple class, let us call it library. So there is a class name here, and on self it defines the book, and the location of book is a, this means a partial function to self, and on self equal to it defines the domain of location, the function book location pair. How to add a book location. Here for that we will be using add to library class. Then some changes in the library. Delta means changes. It is going to make some changes to the library system. A book, and then it is type book, and the export is a self. So a book does not belong to on self, is not in the on self. It means that we are going to find the domain of location. We are going to do a union so that a book is now becomes a partial function of a export. Self, we can now do some proof that on self equal to on self dash equal to on self union a book. For that proof on self equal to domain of location dash, and domain of location, that is the location dash is location or union a book partial function a export. And add to library suffix domain of location union domain of a book, like the fact about the domain, and then next we present the fact about the functions, this function, and finally invariant before whether it implies. So hand proof. In addition to adding that that book location pair, we can add another function and that given the name of a book, it finds itself. So where to find given a book where it is located. Find location to the library. It does not make any change to the library. We simply has to find where the book is. So we are defining this book and self, and again we are going to check whether it is on the on self, and then if found, whether it is on the location of the book. The new indicates that the operation find location has induced no change of state in the library function. We simply have to, it is a mathematical equivalent to onSelf dash equal to onSelf and location dash equal to location, which due to rules of precedence all may be written as on equal to on. Okay. And we simply need to find the location of that simple book. That means another operation may be used to find the contents of a cell, and which may be defined as like this. Here also we need to find what the cell contains given a cell location or a cell number, like that. It also makes no change to the library system, so we use a symbol and we define this types and functions in order to check for the books. That's all. Thank you.